Well, good afternoon, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? We're going to be diving into a new topic. Topic 7 is all about adding and subtracting fractions and mixed numbers. And so there are a number of sections that correspond to the book. There's also going to be some bonus sections which should hopefully be a review, but just in case, here it is. So today we're going to talk about equivalent fractions, and that's that I can find other fractions that represent the same part of a whole. So just some quick vocabulary review. Hopefully you're telling yourself what these words mean. You might pause and check yourself, and then I'm going to put them up on the board. All right. So a numerator is the top of a fraction. The denominator is the bottom of a fraction. So here we have the fraction 2/3. Numerator 2, denominator 3. Equivalent is a fancy word that just means equal to, and a fraction is a part of a whole. So, in your notes, let's highlight this essential idea. Right, that 1 out of 1, 2 out of 2, 3 out of 3, 4 out of 4, 5 out of 5 they're all equivalent forms of one whole. And what I'm curious here is how this can be. How I can have all of these pizzas right, how is it possible that all of these are equivalent fractions? And so if you're thinking in your head, you know, Mr. Heckman, it's because I'm eating the entire pizza. Right here, I ate the whole pizza. I just ate 1 out of 1 slices. And here, I ate the whole pizza. I just ate 2 out of 2 slices. I ate 3 out of 3 slices. 4 out of 4 slices. Right? If I had a 5th pizza cut into 5s and I ate all 5 slices, I ate 1 whole pizza. If I had a pizza cut into 1,000,000 slices and I ate all 1,000,000 of them, right, this is still 1 whole, 1,000,000 out of 1,000,000. So that's important because we can use that information to create equivalent fractions. So when you multiply or divide by 1 whole, your number stays the same. The value stays the same. And what property is that? That is the identity property. We'll start on the right and work left. I don't know, I'm feeling weird today. 5,678 divided by 1 stays the same. 234 divided by 1, you got it, stays the same. 87 times 1, you got it, stays the same. 9 times 1, you got it, stays 9. Equivalent fractions represent the same part of a whole because they're a fraction, but the pieces are different sizes. Right? In this case, right, I have a pizza cut into 2 slices. I eat 1 of them, that's a half. If I multiply 1/2 by any form of 1, in this case we're going to do 2 over 2. 1 times 2 is 2. 2 times 2 is 4. What I get here is 2/4. Notice how this is half the pizza, right? Half the pizza right here. This is half the pizza. It just so happens that my 2 out of 4, my pieces are a little bit smaller. So 2 out of 4 divided by 2 out of 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Here are some problems for you to try. I would recommend pausing the screen and trying them, and then unpause it and check the answers. I realized after I asked you to pause it that for numbers 1 and 2, there are really an infinite amount of answers, because as long as you multiplied it by a number that was the same in the numerator and the denominator, you're multiplying it by 1, and so your equivalent fraction would have stayed the same. These are 2 possible answers. On 3 and 4, though, it changes a little bit because you need to divide by something that both the numerator and the denominator have in common. So 15 over 20, right? The only thing that these two numbers have in common is 5. 4 gets even a little bit trickier because they technically have 3 different things in common. You could divide them by 8. That would be your best answer, 4/5. You could have divided by 4 over 4, 8/10. That's an equivalent fraction. You could have also divided by 2 over 2. That's an equivalent fraction. So your next steps, right, are to complete the IXL activity, right? And you need a SMART score of 85. Thank you so much. Have a great day.